Well, hi, good morning. Thanks for joining me in my shop here for what may very well be the last day for this radio. So, yes, it's upside down. I've left it upside down just now because I want to measure the value of the output tube bias before I turn the radio right side up and get it ready for doing the alignment. Behind me here is the cabinet, ready to go. So, first order of business now, I changed the filter capacitors, so that's call it a high risk operation in that if you make a mistake it's right in the power supply. So for sure we want to start it with the dim bulbs, but I don't think there's a mistake in there. I got my voltmeter ready here. Here we go, watching the lights. Okay, plugging the radio in. That's what the light said. Getting rid of an extra cord here. Now, as you can see, I don't have the antenna connected. I don't have the push buttons plugged in, so there's no audio. Just interested in measuring this voltage here, bias voltage. Okay, let's try again. Here we go. Okay, that's normal light operation. You can imagine my little capacitors just took a shot of 500 volts there briefly. Okay, let's just check B plus first. Okay, so the meter is on the 500 volt scale. Oh, we're still on dim bulbs. Okay, right. Hey, what's going on there? That probably kept the 500 volts from appearing. Starting it up with the dim bulbs. That's 240 volts. That sounds pretty healthy to me. And now the bias voltage, which is the drop on the cathode resistor. I think I'm going to step in front of no. Okay, this is the bias voltage. 15 volt scale, it's about 15 volts. It's just around 15 volts. So if we look at the different tubes and what the bias is that they're looking for, this is out of a book. These are not measurements. So the tube that's supposed to be in there would be around 16 volts. It would the radio would be set up for that, hopefully, I guess. 6K6, a little more voltage bias to give you that kind of current at that kind of voltage. So we're a little low, but not terribly low. Good enough. Good enough. Okay, so shut it off before I forget. So now I'm going to set the radio up so I can redo the alignment top to bottom, and then the last stage after, because when I did some earlier studies I discovered the 19 meter band appeared to be way bad. That's I really booped that one up, it seems. So we'll sort that out. We'll get it aligned as best I can on the bench. Then it's into the cabinet so we can see the actual glass dial markings and do the final oscillator adjustments. Most of the bands here are spread bands. And so all there really is an oscillator adjustment, or I can make a minor oscillator adjustment without worrying about any other alignment issues. Very good. Okay. Okay, I think I'm just about ready to go. So to do the alignment, I'll be paying attention obviously to the meter at the bottom. That's going to be measuring the AVC voltage, and I'll try to do this at the lowest AVC voltage I can get away with. We're just looking for peaks. We're not looking for any particular voltage. So, and in the top left corner is my SDR. The reason that's on is because I'm going to use it to detect the local oscillator frequency of the radio, and that helps me confirm things as opposed to not using it. Okay. let's switch on the set here, and the name of the game, the first name of the game is Make the Radio Work a Bit. So I know I've got all the parts plugged in. I've got the push buttons are plugged in back there. You can see the magic eye. It's staring at nobody and nothing. That's okay. Okay, let's switch it on. Okay, dim bulbs first. All is good. Good, good, good. Change the while it's warming up. I changed the frequency of my SDR down into the. Well, first we're going to be doing the IF. So the local oscillator frequency is really not important. So, and what we'll do is maybe we can zoom in on the IF area, which is right in here, just for interest's sake. While we're doing this, zooming in. Oh my gosh! Okay, there's something new. Well, my shop is full of smoke here, so I know exactly what happened there. Yeah, so I gotta get out of here for a while. Okay, been out of here for quite a while. Smoke has cleared. Well, you know what? If you get on an airplane and you see me in the pilot seat, get off that airplane right away. So I came in this morning getting ready to do the video that you're watching now, and I just glanced at the two little capacitors that I installed, and I thought to myself, they don't look identical. They should be identical. But I thought, one of them looks a little fat. I wonder if I put the wrong one in there. And then I just went off and totally forgot about that observation completely until there was smoke coming out of it. So I think that's what's happened here, is I simply mixed up some capacitors on my bench and stuck in a low voltage one there. Well, that's what I think happened, but I am watching Mayday on TV, you know, the program where they investigate accidents. And it's time to investigate an accident here. Let's fly in with our close camera, see if we can read anything before I cut the capacitor out. He popped his top, I say. So I can just tone down the lighting here a little bit. Okay. He's popped his top. Okay, so the one over there, I cleverly installed so we could read the name brand, and the one that popped, I don't think I'm going to be able to see it. Wanted all the words to melt off of it? Well, it's pretty obvious which one popped. See, they don't look to be the same size, do they? How could I have not noticed that? And that's what I'd be saying to the co-pilot just as we crash. Yeah, I could hear the co-pilot saying to me, "Pilot Jim, I don't think we're going to make it." And I'd say, "Don't worry, we'll make it to the crash site." Okay, I've chopped it out. Let's take a look at what I stuck in there. A 160 volt capacitor. Duh. Well, I guess this answers the question. Well, you know, what if you stick a 160 volt capacitor into a 250, 300 volt circuit? The other thing too is if you're on an airplane and the pilot starts talking about the electronics technician who's been working on the aircraft and his name is Jim, you should get off that aircraft right away. just in case it's me. Okay, so stupid mistake. I got a lot of them. You need some stupid mistakes? Come see me. I got tons to share. I'm gonna put the proper capacitor in there now. Okay, doing my own little accident investigation here. How did I make this mistake? So here's my tray of capacitors. You see I have the size there, but I don't have the voltage written because there's different voltages in here. That's part of the problem right there. So this is the tub of 4.7s here. That's a 4.7 400. That's what I wanted to install. But right in it, right beside it is 4.7 160. Now, you know, when I was doing this and looking through the tray, I thought to myself, I should move all these 160s to my 160 bag. But then I thought, no, because the size is actually correct here, 4.7, so I'll just leave them in there. I had a couple of these bigger ones in my hand and stuff like that. Oh my gosh, how could I go from being totally conscious to being completely stupid? Well, it's because I'm a human being. We do make mistakes, don't we? Okay, so I have the correct capacitor. A 400 volt rating is going to do it. Its brother hung in there while the other guy fried up. Okay, so I'm going to install this now. You know, I did all that logistics thinking about how to approach installing these capacitors so they would be the easiest and most direct way of doing it with the least hassle for me, and now look where I am. Best laid plans of mice and men. Isn't that how that goes? Okay. In it goes. Okay, so I'm down on my hands and knees here. Down on my hands and knees praying this works. To get it good enough, I can solder it and get some stability on one leg. One leg of the capacitor, not my leg. Okay, I think I can solder that. Definitely the negative going to the ground. I'm not making that mistake. I bet you thought that's what it was. When you first saw the smoke come out, you thought, oh, he's put it in backwards. But I knew better. That's the kind of thing you don't want to hear your pilot saying, you know, stuff like just before they, you know, as the plane is going out of control. No, I knew there'd be trouble with that. Oh, that's right, I was going to check that thing. Yeah. Okay. In with the solder. Okay, well, you know what? I retrieved this from the garbage can because I think it might be interesting to test it and see how it tests. Because it didn't pop and it didn't go bang. I don't think it actually shorted out. I think it just got really hot and the pressure inside caused it to pop at the top. So let's just see what it'll measure out at. Maybe I'll put it back in my box. Use it on some other radio. Okay, here we go. No, I wouldn't do that. So it thinks it's 1,000 nanofarad. The V loss is 10%. 1,000 nanofarads is 0.001. That's a far cry from the 4.7 it should be. Yeah, so I think that pretty much proves this guy is cooked and finished. Okay, next thing, we'll get back to the radio and carry on, see what catches fire next. Okay, I think I'm ready to go here. So let's start up the radio again. Let's plug it in. Maybe that'll help a little bit. Okay, try again. Oops. Oh, sorry about that. Sort of smashed my microphone. Here we go. Dim bulb's good. Got the radio aimed right at me here. Tip it towards the camera in case we get another pop out of it. Not likely. Okay, looks good. Full power. Okay, hear a little bit coming out of the speaker. Now, just make sure we're on. Okay, so this is the broadcast band VFO, and the radio's working. That's a good sign. How come our meter is going the wrong way? It's because I had the meter set wrong. It's a negative voltage. There we are, and that's okay, looks good. Okay, I'm going to pick a spot now below. About as low as it's going to go there. Oh, something at my door. Oh, just take the thing out of the oven. Okay. Great. So if you look on the SDR, we see a curve here, like that. That's the response. Now let's zoom in a little further here. Okay, so 455 is right here. Let me put the red. Put the red on 455. Here we are. So we really want this response curve to be peaking 455. Now this thing here is some signal being picked up by the radio. So get away from all signals. Easier said than done. These are all noises here in my shop. You're seeing roll through the IF. Yeah, quiet spot. I don't think there is such a thing. Let's go down the other end. That's the end of the road in my tuning. So we can't quite get that giganto noise in there. This is at tune. The radio's tuned to 530 right now, or somewhere in that range. So that noise is just below. I'm never going to find a spot that's free of that. But what we can do is, we don't have to be on the broadcast band. We can go up on some other band here. A quieter one. Even this guy's picking stuff up. There we are. That's better. There. So now I think all we're left with is the IF response, which to me is peaking around 451, 452. So now I'm going to send in a signal from a signal generator. Gee, I think I'm going to kill the radio when I hook this up. So this is connecting to the grid of the mixer tube. I think it's just going to silence the radio. No, did not. Did not. I'm surprised. Okay, so I'm going to dial up 455 and we should hear it and see it. I have a very low signal level right now. Hear and see nothing. Okay, checking to see what I'm doing wrong. I think everything's okay. Let's go a little more power. A little more. This is not correct. So I'm looking on the SDR to see if I can see it. I don't see it in there at all. It's another day in Jim's shop here. Let me check the calibration on the output here. It's pretty good actually. It's very close. Could be I just have to drive a very high signal into the radio at this point for it to show up. Oh my gosh, it's not. Something is not right here. Okay, so let me just check and make sure I'm on the right pin. Yeah, wrong pin. Okay, wrong pin. Wrong pin. I'm on pin 1 instead of pin 8. I think I'm going to turn off the set. I turn down the output here. I'm going to move this guy. I don't know what I was hooked up to there, but it wasn't the right thing. Of course it goes on where the green wire is. Okay, let's try again. Here we go. Yeah, see, I got lots of mistakes. I can share them out. Other people can enjoy them. I guess that's what I'm kind of doing with these videos. Now probably the radio's gone quiet. Let me disconnect this. Right, so this is quiet. That's right. That should have been my first sign something was wrong. Okay, we're going back on. Notice the voltage dropped almost nothing. That's not bad. That's helpful. Now we'll see if the radio can hear this very low signal. Turn the volume way up. No, so we'll go up. There it is. See, the meter's hardly moving. Let me make it more sensitive. Okay, that's the bottom. I can see it come in. Okay, get the meter at the top. And what happened to the SDR display that it disappeared? Oh, probably when I connected, I wasn't watching, but probably when I connected that, it knocked that out. So it reduced the noise so much. I've turned the volume way up. Doesn't make it obvious what's happened. Okay, we're good to go here. So I peaked the meter and we're at 452. Why not 455? What happened? Okay, so we're going to adjust it up to 455. Okay, so on my counter, that's 455. And now we'll start peaking the coils, transformers rather. Okay, watching the meter. That one's not off. Let's try this one. Okay, you know, watching the meter. Wow, so this screw is cranking down tight at this point. Why would that ever be? No, it's not going to come back, I don't think. Wow, that's like cranked right to its limit. Oh no, it was just a little sticky spot. Okay, that's done. I'll do the tops. Okay. It's hard to get the tool to settle in the trouble working a screwdriver now. Okay, here we go. Show me an improvement. See, that's nothing. So that's hardly adjusted. Let's move this around and see if it goes down in both directions. Down, down. So now this is tuned to just 4. It's really close. We're talking about a hair's difference here. Well, let's get that here. Okay, watching really closely on the meter now. Down. Up a touch. Okay, do the top of that same transformer. Down. Up a touch. And we're talking a tiny amount here. Okay, next one. Oh shoot, I moved it. Okay. I think we got a little more to this one. Okay, right there. Top of that one. What an annoying tool. There. Okay, watching the meter again. Up just a touch in one direction there. Okay, can I possibly get it any better? Okay, let's watch now. Watching the meter. Adjusting the IF frequency. The peak is right there. And the number is 455. Okay, I'm not going to get any better than that. I'm going to disconnect this. That'll put the noise back in from the front of the radio. It should give us a nice display on the SDR. And now what do we see? It's dead on 455. Excellent. Okay. Excellent. So refined that. Now what's left is all the alignment activities for all the rest of the bands. It's already noon. I've been a little slack today. I've been sitting in front of the TV too much while I'm doing this. This might be the end of the video here, because I'm just going to check and see how much I've got already before I go any further. So I think all I want to do for the rest of today, about a half an hour of video collected now, is just double check the findings I found earlier that suggested the 19 meter band was just way off in alignment. So what I'm going to do is I'm going to dial the radio pointer to right in the middle. There we are. So it's right here. And then I'm simply going to go band to band to band and check and see just how close it is that the radio tunes these frequencies that are listed right in here. And find out just if there's a really gross error or not in there. And that should be enough for today, I think. Okay, so if we're going to do that, we will go to the top band here. The top band. And the top band in the middle is basically 18.5 megahertz. So I'm going to take this and put it on the antenna. Okay. And then we're going to shoot 18.5 into the radio. 18.5. A little bit of volume, please. I should really pull this out. Wow, gonna make a difference, eh? Huh. Just having that wire there. Okay. 18.5. So it's 18.3. It's close. That's not so bad. I wouldn't call that way out. Next band down should be 15.2 in the middle. This is the one that I think is way off. Right by, didn't hear it. So that's a sign something's wrong. Let's go up in the power. Yeah, this one's way off. So it should be 15.2 and it's showing 15.7. So this is off. It's interesting, it's off by roughly the amount of the IF, which means maybe I've aligned it on the image or something like that has happened, as much as I try to avoid that. Okay, so that confirms the 19 meter band is bad. Let's keep going though. Next one would be 25 meter band. This should be 11.778 or so, 11.78, something like that. Need it up to be so loud. 11.78. Hey, where are you? It's very insensitive. There it is though. So let's do a check of this. If again I've misaligned this on the image or something like that, I think we would go, I don't know. I'm going to go fishing. Let's go fishing. See if there's a stronger signal somewhere. Doesn't seem like it. This is weak. Very weak. And on that band I made no notes. I'm going to put in the notes here. Whoops. Whoop, whoop, whoop. This band is weak. Okay, down another. Don't know why it's weak. Now we're on the 31 meter band. Just because I do, if you notice, I do make mistakes. I'm going to grab the mirror. Just make sure I'm on 31. Yeah. In this band, we should be around 9.57, something like that. 9.57. Right at the limits of my signal generator here. Didn't hear it. There, 9.557. I thought it would be 9. That's good. Good strong signal. So it's close. And then the last one is the B band. In the B band, we should be around 3.7 if everything is hunky-dory. 3.7. Oops, shouldn't have done that. .7. 3.5. The center is really hard to see. I think it's right here. Let me check that. And this, there's nothing to check. There's nothing to check on the radio channel. There's no scale there, man. What are you doing? So we're roughly got the radio tuned here, 3.5. So close. It's very close. Close enough. We have one band that is just as I thought before. One band way out, one band weak. We'll see what happens with that tomorrow. That's great. So thanks a lot for watching, and going slow and taking it easy here because this is the last, well, almost the last alignment. It's the last bench alignment. The last thing will be just a small touch-ups, hopefully, once it's back in the cabinet, which I thought it would be in today, but it's not going to get there today. Okay, that's good. Thanks a lot for watching. See you tomorrow.